We've all been there, in the middle of a job, everything going smoothly, until boom, you're missing a part. United Refrigeration is your one-stop shop for all your refrigeration needs. Use your computer or smartphone to go to www.uri.com at any time of day or night to check stock on your favorite brands, such as Copeland, Sporlan, Carlisle compressors, Danfoss, Emerson CPC boards and sensors, Carrel, Hussmann parts, and K2Therm. United Refrigeration, Inc. is home to these brands and many more. Looking for information on refrigerant conversions or refrigerant banking? Quick access links on the homepage can get you to the information you need. All approved accounts are able to see live to-the-minute inventory and pricing. Product not in stock at your local branch? No problem. Use the Nearby Stock feature to find a local branch that does have what you need. Are you looking for a branch address, phone number, or after-hours number? That's all available as well. Just click on the branch locator and search for your local branch. Have a model number and looking for a replacement part? www.uri.com/ARP has a vast list of quick pick replacement parts. Just search for the model number of the equipment you're working on and click the Replacement Parts tab. If you don't have an account, click the Register button and we'll have you online in no time. With more than 400 locations in North America, each United Refrigeration branch is fully stocked for immediate pickup. Our branch employees have in-depth technical knowledge, so we can help you get what you need when you need it. Visit your local store or www.uri.com/ARP today. United Refrigeration, Inc. has all your solutions down cold.
John, how can you always have the right TV for the right application without carrying hundreds of valves on your truck?
You can carry the hundreds of valves on a trailer behind your truck.
That's too funny. That would work, but how are you going to do that? Maybe there's an easier way.
You can use Sporlan's interchangeable cartridge style Type Q and Type BQ TEVs. Type Q is a conventional design and Type BQ is a ballast for TEV.
Well, come on. I need easy. How easy is it?
Easy as 1, 2, 3.
And it serves thousands of unique applications. So what's the process? How do I put this together?
First, select the thermostatic element assembly. Then you select the body that you need. Then you select the right size cartridge for the application to get the proper capacity TEV for your application. Then I guess it should also be said you want to actually assemble those into a single valve.
That'd probably be a good idea. These easy to select and assemble valves mean you're always carrying the right for the right job. If the folks want to learn more, what do they do?
You can go to sporlan.com and find more information on the Type Q and BQ thermostatic expansion valves.
I guess that's Jim and John for Sporlan signing off.
Good evening, everybody. Welcome to Advanced Refrigeration Podcast. You're the host, Brett Wenzel and Kevin Compass. And yeah, we're live. How you doing?
Why are we live?
I mean, we're not live. Just record it.
Oh, I'm exhausted.
I was gonna say, you sound like you're kind of dragging ass. What's been heating on the old noggin? What have you been working on this week?
Oh, I'm doing Danfoss EMS controls or upgrades from CPC to Danfoss, and it's really been trying my patience.
Why is that?
Oh well, just like everything we touch is just cobbled together, and there's sensors deleted all over the place that weren't supposed to be, and there's temp sensors all over the store with minus 20 offsets, and we're doing these resistor kits, and they have a 50% working. We're at 50% right now. 50% of these resistors work, the other 50% don't. And we had to end up changing the sensor anyway after spending an hour messing around with it.
Really?
Yeah.
Actually, I talked to a kid the other day who was having problems with Danfoss. He man, it was the weirdest thing. I've never seen where the board itself would show that the whole module was offline, but then when you go into the controller, it actually said online. didn't have any devices absent. But on top of that, it was really weird because the temperature basically just kind of flatlined. So whatever it was at prior, it just kind of failed out. And I had to use the bat phone. I had to call Yoder. Thank God he was actually on call that night. And I don't know what the end result is yet because like nothing as far as programming wise kind of made sense. The only difference that we found, or that the guy ended up finding out, and he assured me that there was no type of corrosion because this just got installed. But yeah, he found corrosion on the board, and it actually, if you look at the picture kind of deep, it looks like it might have been burned and lit. You know what I mean?
Yeah, I don't know. I've had a lot of strange issues. Like we've had boards that say they're online but won't come online in the controller. Like they're communicating but won't show online in the controller. But like half the board will be online. It, it's been very trying for me. I'm trying not to be negative.
How's that working for you?
Not good. Not good. It's why in God's name would they not put something that says before you go to like change a number on something like of circuits? Like if you go from like 10 circuits, you go to 11 and you actually hit 0. Why in God's name would you let somebody delete all the circuits?
Wait, one more time?
So if you go to like, say you go to add a circuit and you have like 10, say for example, 10 circuits and you go to
Yeah.
put 11 in and you hit the 0 and you accidentally make it 0 circuits, it deletes all the circuits out of the controller.
Every
No,
single one, even the ones that you weren't even
everything.
touching?
Yeah, every single one. Like not no like, are you sure you want to do this? Like, are you about to realize you're about to do this? It's just
Yeah.
like straight 0, up, gone. Everything's gone.
What the fuck? What happened when you called them with that? What'd they
No,
say?
nothing. I didn't call. I just thought about putting the barrel in my mouth and just stayed an extra 2 hours and redid what I messed up.
So let me show you this really, really quick. Why is it? There we go. This. There. See that?
They don't look brand new. They looks like 10 years old.
Well, but that's what I'm saying. So what's weird is that you have this corrosion here, but like look how it's like shiny right there, and it looks like it potentially like parked through the fucking. You know what I mean? But he said he pulled it off and he didn't see any corrosion on the front end side, but that doesn't necessarily mean you don't have any corrosion on the back. Essentially, I told him to replace it until Danfoss has a resolution for you. Because at first I thought it was one of those really rando things that some kind of firmware garbage that's the problem. It ends up being like something with the firmware or whatever where they have to redo something. Because like I said, every single 3 and 4 nodes 3 and 4 would basically start blinking like craziness. But like I said, the controller wouldn't show that the cases were offline, but yet they were flatlining and they didn't go over to the last spot until. Well, that was the weirdest thing ever.
My computer just like booted up all the way. Why would it do? Just like start like freaking out?
Yeah, that was so weird. Alright. I thought I did something. I'm like, why does it sound like the lawnmower man? It was the most fucked up thing ever.
Yeah, I wasn't even talking. You were talking.
Yeah. So what'd you think now that like this year you had enough time to like kind of finagle stuff around like AHR, like you weren't being rushed or whatever? How'd you actually dig it?
It's a lot. It's just a lot to take in.
Yeah.
More salesy than I I had hoped. I thought there'd be a little more training stuff, but I mean, obviously, it's a giant sales show.
No, I mean that's what it's for. It's made for those backroom deals.
Zero direction though on anything.
So if anyone didn't hear us talking about this on the podcast last week, yeah, I got lost from my vehicle for probably about a good half an hour to 45 minutes. I think you were in the parking deck for what, about an hour?
That whole fucking town is just like a gaggle fuck of like just like no direction and like just shit everywhere.
Yeah, it's I don't know if I'm sure people have been, but like, man, trying to park and get around, like, it's way easier if you just Ubered it, which is probably going to be what I'm gonna do when we go to Chicago or whatever. But yeah, like you have parking decks that are ruby, diamond, uh, gold, red, and just whatever. And then you'll have, even though it'll say that you're in the orange parking lot, all the placards and shit will have red on them, kind of just fucking you off. And
Starting 2 parking lots, you're good.
yeah,
North and south, that's it.
yeah. I don't know. I was tired that day, the day that I got in, because Sunday was kind of hectic, but I totally spaced when I left to even take a picture. I just remember pulling in and just remembering at least that it was the diamond parking lot. Because if
Oh,
God forbid, I'd still be looking for my car.
I took a picture and it was red like stall number 37 or 37 and that was not in the red parking garage. It was in the orange parking garage level red.
That's awesome. No, man, I had fun. I mean, I think we made a lot of great connections. We talked to Andre and Waynard, and like, man, that was freaking amazing. That whole conversation, just talking about some of the future stuff going on. Uh man, I'm just it was a lot. And unfortunately I got to actually go down to Thursday. I visited the lab at Heatcraft. They're coming out with some new products, and then Hill Phoenix. I got to go down to there, and it was really cool, like seeing out actually how they go from point A to point B, and just the assembly line. Dude, they're knocking out like 30 racks a day. Tonight we're gonna talk about LPA, not IPA, LPA, liquid pump amplification. Basically, it's to get a little bit more efficiency at the refrigerant. They're using a pump in order to pump that refrigerant all abouts in the system. So that's what we're going to talk about. Yeah, the only customers that I'm aware of that does this as far as commercial would be Walmart, unless you're aware of any else, Kevin.
Oh, there's some LPA pumps on this 80s racks that I'm doing these conversions on, which is what sparked this because I was messing around with them today trying to start them back up. They probably haven't run in 10 years.
Did you have a whole bunch of leaks on the seals?
No, they're all open. They're hermetically sealed.
Oh, okay.
But they were all open already, so they all have pressure on them. So, but guys, LPA, liquid pumped over feed systems. There's a couple different ways you could set this up, but at its core, basically what you are doing is you are using a pump on the liquid line to move liquid refrigerant to the evaporators.
What kind of pump?
It could be a hermetically sealed pump. It could be a driven or a non-hermetically sealed pump, but
No, I get it. They're using centrifugal pumps, though, right?
centrifugal pumps. Yeah,
Okay, I just want to make sure.
you can use a gear pump too.
Really?
Some older ones are geared, but they're using centrifugal pumps. And the whole premise behind this is, guys, is as you lower your head pressure and you get it in the tank where you would normally have flash gas get into your evaporators, this liquid pump helps move that liquid refrigerant and keep a full column of liquid inside the liquid line, which allows those metering devices to get a full column of liquid, not flash gas. But at its core, all this basically is a liquid pump that is moving liquid refrigerant around. Now, the benefit of having this liquid pump, you could do some other things with it, which we'll go over once we get more of this premise down, and some other cool stuff they can accomplish with this, and what Walmart is accomplishing with this. But we're going to go over the basics, guys. So the premise of doing this, think about this liquid pump. It's tiny, it's small. I mean, the ones that I've seen are drawing like 3 to 4 amps. Think about it like this: middle of wintertime, you're driving down that head pressure. Okay, you drive down that head pressure, you get that compression ratio closer and closer, or those pressures closer and closer and closer, and then you reduce that compression ratio even more. So now you take that 10 horsepower compressor, running it
let's say 20-pound suction and 250-pound discharge, and you slam that head pressure down to 95 pounds. Okay. Now you're 95 over 20 pounds. So your compression ratio is just sliced in half. So what this is essentially doing is taking that 10 horsepower compressor and making it bigger. It's allowing that compressor to do more work with the same compressor. So what does that do? It allows you to shed compressors off the rack. Okay. You're shedding compressors off the rack. Say you may be running 4 compressors. Now you're running 2 compressors that are doing the work of 4 compressors. Now, you do this at the risk of your fan horsepower, but it's a lot cheaper to run a condenser at a higher RPM and a higher amp draw is to run a compressor. Running that condenser at full amps may cost as much as one compressor running, if even that. And then as it gets colder outside, the amount of fan horsepower you're going to use is going to decrease. So what you're doing is you're dropping this head pressure down to as lows and close to ambient as you can get it. So say we're running the Walmart skids, for example. If you look at them, their set points, I believe, are 95 pounds for the liquid injection. I'm sorry, the pump to kick on.
Yeah.
So I'm sorry, it's 100 pounds. So at 100 pounds, the liquid pump's going to kick on. It's going to circulate that refrigerant around the store. So they're trying to maintain 100 pounds. And what this pump is doing is it's driving off a VFD. That VFD is looking at a delta pressure between the inlet and outlet of the pump of 5 pounds. It's trying to raise it up 5 pounds. So the outlet of that pump will be at 105 pounds. So if you're at 100 pounds in the inlet, it's going to raise it to 105 pounds. Okay, that's going to pump liquid refrigerant through the liquid header into the store, through your liquid lines, into your metering devices. Now, what this is going to do is it's going to assure that metering device has 100% liquid at it because you have that liquid being pumped out there. Now, as where it would kind of get lazy and sit in the receiver or sit in the condenser when you're running that low ahead, it gets lazy and doesn't want to really move. But you have that pumping force behind it, that velocity pushing it now. Instead of that pressure, you have that velocity pushing it and causing it to be forced into the store. Now, these pumps, I will give you guys a heads up. There's 2 transistors in there. Those packed angle valves are prone to leak. So making sure that they're backseated real good, you Teflon and nylog the caps. I mean, you'll have no problems with them then. Now, there's a strainer on these pumps. So we've had a couple of these strainers plug up. They're just like the strainers in a CO2 system. They're not real fine, but like there's enough in there where enough soot and like crap from install. Go ahead, Brett.
So I've seen the ones on the racks where they're doing the LPA, but are they doing any single systems with LPA? Like example, I'd never seen this before implemented until I was like, as far as like smaller commercial shit, like they do it in ammonia all the time, but like the other stuff, the single systems, have you ever had one that was actually running off of that?
No.
The rack?
No.
Okay. Because they've been making those, because these are raw units, right? Raw? Yeah. So they've been making them for years. So like I said, I never, the first time I saw a single system with that on there, like I kind of blew my top. I was like, wow, that's fucking weird. I've never seen it. Go ahead. Sorry.
I mean, it's a little bit overkill for a single system, but yeah, like, so there's strainers on these guys. Make sure the strainers are clean. You can check a pressure drop across them. There's a sight glass there. Make sure you're getting a full column to that pump. If you do not have a full column to that pump, it will cause damage to that pump. Pump vapor.
It'll cavitate really, 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 really.
Correct. Which is why that system is tied into the receiver level. And if there's a low receiver level, it locks the liquid pump out because
Gotcha.
they don't want it to cavitate. If you cavitate the pump, it'll destroy the pump.
100%.
So that is a number one thing. You need to make sure that those racks have enough liquid refrigerant in them to run. Now, when they're doing this whole thing, they're changing all the VFD set points. So this is very important. Like if you go into a store that has one of these, do not attempt to like try to set these settings up higher. You're going to cause problems. So they're changing compactor values and all the VFD settings. They're changing split set points. So they're lowering the split way down. So that way that they can take advantage of the most of the natural subcooling that they can and get the pressure as low as they can without the split causing it issues. Now they're splitting it like 95 pounds for
Uh,
404.
splitting the condenser?
Yes.
Gotcha.
So they're splitting it 95 pounds and they're on splitting at 125 pounds. So whereas it before would be like a 175 on split and like 130, I think it's like 130 split usually. So they're lowering that way down to take advantage of that. Now, and that's allowing that pump to come on. That pump is going to cut in anytime the pressure is lower than 100 pounds. Your liquid level is above the alarm threshold, and it's calling to run. Now there's a VFD in there where it's going to try to maintain that delta pressure. There's a Corel controller in these. The Corel controller is doing all the math and telling the VFD to drive. So, I mean, that part of it's pretty locked down, but all that information's in there. The liquid pump overfeed stuff, or overfeed, the liquid pump
Amplification.
yeah.
Just say LPA. Say LPA.
It's been a long day.
It sounds like it.
So the LPA system, guys, is essentially just moving that liquid around. Now we get to the other side of this, which is the other huge benefit. Now that we're increasing that liquid pressure, that 5 pound difference. So let's say 100 pounds coming in, you're 105 coming out. Your liquid pressure on the outlet of that pump should be higher than your discharge pressure because you're amplifying that pressure higher than what the discharge pressure should be. So
Why?
because you're raising that pressure up. So say your discharge pressure is 100 pounds through the condenser, no pressure.
Oh, right, because it's going to increase it by 20 or 30 pounds when it goes to pump it out. When it goes to
No,
pump it.
it's five. It's set point's 5 pounds.
Oh, okay, that's right, because it's trying to maintain. Okay, never mind. Go ahead,
So
continue.
now think of it like this: you're 5 pounds over your discharge pressure. Now you're still moving at refrigerant because you have that pump. It's pushing that refrigerant into the store, so that it's
Gotcha.
pumping away from the rack. Now think about it like this: in the middle of summertime, we could utilize this pump too, to pump that pressure up. And what we're basically going to do is we're going to raise that liquid pressure 5 pounds over discharge, and we're going to push liquid refrigerant into the discharge line.
Okay.
Now we're doing this to de-superheat the discharge line. So we're dumping liquid refrigerant into the discharge line and causing it to de-superheat.
Almost like the cool jet systems, like the screw compressor that basically it's the oil cooling system where they take that the first receiver coming from the drain leg before it goes to the railroad receiver, and basically they're using that pressure and pushing that back up into the whatever boils off up into the discharge side of the condenser in order for it to be essentially equalized. So they're utilizing that pump, the side effect of the pump pressure in order to get basically almost like liquid injection, right? Because there's no heat exchanger.
Yeah. So what they're doing with this is they're taking two CDS valves and they pipe them in parallel. And what they're doing is injecting into the split and full side. They're injecting liquid refrigerant in there and it's causing it to flash off instantly because we're able to inject liquid in there because we have a pressure difference. So we're 5 pounds over the discharge because that pump is moving that pressure up. So it's allowing it to inject. Now it modulates these CDS2 valves in order to inject liquid refrigerant in there. Now, when it's doing this is it's desuperheating the 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 vapor inside the discharge line. Oh,
You
man.
you're fine. So you're essentially getting rid of some of your total heat rejection numbers. So your BTU load is actually lesser on the condenser than what it typically would.
Correct, which it allows you to make the condenser essentially larger.
Yes.
So you're able to now cool more in the middle of summertime. You get two benefits out of this. You're gonna get lower head pressure
Mhm.
for very little cost. I mean, this pump may draw like 3 amps. This thing's moving. It's tiny. It's costing no kW to use this pump compared to what it would cost to run all these compressors for 20 hours of 270, 280 pounds of head pressure. Now
Yeah.
you may be able to get it down to 250, down to ambient basically. And it essentially makes the TD on the condenser less because now you're making the condenser more efficient and the
Mhm.
just running you're able to run a lower head pressure, and you're also able to get more subcooling out of the condenser now because more of that condenser is doing subcooling instead of desuperheating. So in the middle of summertime when we're struggling and you may only get 1 to 2 degrees of subcooling out of this condenser, you may get 5 to 7 degrees of subcooling now. I mean, you're getting much richer liquid coming out of that condenser. So it's all around a much better application for this. Injecting that liquid is like a huge benefit when you get your head around it, like the benefit of injecting that liquid on there. And I mean, they're kind of like they're not really getting real ballsy with it. Like they're injecting, I think at 170-degree cut in is when they start injecting the liquid. I had to look at the sheet. Oh, over 170 pounds they cut in, and then they're trying to maintain a 40-degree delta from the three temp sensors that are on there. So what they have is they have a discharge header, and they have a temp sensor on the line going to the split and full condenser lines, and they're trying to maintain a 40-degree delta. So they're trying to maintain the lines going to the condensers 40 degrees less than the lines going to or the line coming off a discharge header. So they're trying to drop the desuperheat at 40 degrees,
Okay.
essentially.
That's the injection mode is what you're talking about, right? So let's see here. So my discharge. So they're actually looking at the discharge temperature too.
Yep.
So there's different. There's also different reasons. So it probably does it also if the discharge temperature gets too high as well, which will mitigate the amount of superheat going to your compressors as well. They're doing almost the same thing as what this formula kind of looks very comparable to what they're doing on the uh, LNP CO2 racks with the liquid injection being controlled off of the medium temp superheat as well as the discharge actual temp.
Well, yeah, I mean that's the same, essentially the same way they're doing the desuperheating.
Yeah.
I mean, that's what they're doing here. They're desuperheating that. I mean, it's kind of crazy looking at it. Like you're seeing the liquid dump into the discharge line and kind of
Mhm.
look at it like, but then you're looking at this rack that we're doing this controls change over at, and they probably did these pumps 15 years ago. Same concept, just
Mhm.
uh, dumbed down a little bit. No, no receiver controls. So if it runs out of liquid, it's gonna obviously cavitate the pump. No control. It was an RMCC, so I mean, you're very limited on what you could do for your controls there.
Wow, they're even doing liquid injection actually as a proof, some kind of proof thing as well.
Yeah, so it's 300 seconds. So the VFD, it wants to see it. If it doesn't see the VFD running in 300 seconds, it locks it out.
Gotcha.
And all these are remotely monitored by this RAA company. And then
Mhm.
they're also tied into the BMS,
Mhm.
very limited. And then also the other thing is when they were doing these, they upgraded all the holdback valves to Sporlan holdback valves. with
Yes.
CS valves like we were talking about, and then they're actually controlling that pressure off of a Modbus signal from the Corel controller. So the Corel controller is actually doing everything. So attempting to change the holdback setting inside the Sporling controller, it'll let you change it, but then it'll override it as soon as you do it.
And remember, guys, you can get all these conversion kits from Sporlin. Hey guys, today's episode is sponsored by Westermeyer Industries Serviceable Oil Floats. Many oil separators contain an oil float to effectively meter separated oil back to the compressors. Westermeyer Industries has taken this concept and perfected it with their new line of serviceable oil floats. These floats feature an improved design with fewer components, allowing for greater manufacturer consistency and up to 20% increased oil flow versus their legacy models. These floats also feature an integrated magnet to shield the oil path from debris and have been field proven in supermarket applications. Westmeyer Industries offer replacement oil floats not only for their own separators, but also cross-compatible models for our competitor oil separators as well. You can find out more about the Westermeyer Industries serviceable oil floats by visiting westermeyerind.com/floats. Once again, that's westermeyerind.com/float. Let's get on with the episode. Looks boring.
Yeah,
But other than that, I mean, the only problem we had when they put all these in like 2 years ago is the company that did them kind of didn't do the best job, and
Piping what?
yeah, the piping looked like shit. And I have never seen so much soot in pipes for
Wait,
like
what?
as little piping as they did. I mean, they only did like maybe like 15, 20 joints.
Seriously?
Seriously, like I'm talking plugged strainers everywhere. And it was like they were doing like a store a day or like a store every two days, they depending on what they were doing. And it was just I would be there for like 4 days pulling strainers.
So wait, so did you actually do the conversion, or were these units that didn't have LPA and you made them into LPA,
So
or
when 2 years ago, uh, Walmart did this like campaign in Indiana, almost every store in Indiana got these LPA systems.
okay, that's
So
that's
they
where I'm getting at. Go ahead.
Yeah, they came through and they had a contractor that was subbed out by a sub of another sub, and they came through and installed the LPA systems.
Really?
They
So
installed them.
so it was a conventional rack, and they actually converted it.
Correct. Yeah,
Okay.
every store.
Okay. Okay.
So they installed them, turned them on, and left. Didn't say anything, buddy.
Wham bam,
Cool.
thank you, ma'am.
Yeah, 80% of them, the VFDs were programmed wrong. So like we're running service calls and nobody knew about any of this. So it's like we're finding out. I'm emailing people, finding out. Okay, well this is supposed to be set to this. This is how this works. This is how this is supposed to be set. So we're going through and like basically before commissioning happened, we had to commission these things on service calls. But I mean, that was the only downside. And the plug strainers were everywhere. And I'll tell you this: when you're running 115, 120 pounds of liquid pressure,
Mhm.
any dryer that's a quarter plugged or strainer that's a little plugged, it's going to show up.
It's
Any,
gonna exacerbate it so much worse.
yeah, like I mean, any dryer that like at 150 pounds, you had plenty of flow and you were fine. If you had a 5 pound drop on it, you're toast. I mean, liquid lines were like ice cold. I mean, it was hard to tell when stuff was plugged. You had to actually basically like listen for it.
Or if it's actually fucking running.
Yeah.
I mean, it's because I mean, you don't. I mean, you still have. I guess the pump would kind of deafen or dampen the pulsation that you'd see, right? I mean, for the most part, right? You're taking a pulsation and then basically converting into like a straight flow coming off a pump, which is going to be very, very smooth. And so I'm assuming as well, because we're trying to control the differential, right? On our pumps, we are using VFD on the pumps.
Yeah, VFD on the compressors or no?
Either. Is it doing
No,
VFD
no
on the
VFD on the compressors, but there's a VFD on the liquid pump.
okay, and it's just there's no backup. It's just pump or
No.
not.
Once it goes in, once it fails like that, then it either runs pump or no pump.
So is it then automatic? Like where it'll actually bypass the pump?
No.
Oh, are there valves to bypass it?
There is valves to bypass the thing. If you need to bypass the skid, there is a valve to bypass the skid.
Okay, so you're not totally up the creek if God forbid that thing went bad. Because I
I
mean,
mean, you gotta remember
I'd think you'd have a little bit of restriction if you were running the refrigerant through a pump that's not running.
so I mean, there's times it's not running.
Oh, because the pressure's so low already, right?
We're high
Oh, right. Because it's okay. Well,
because
how does that sequence go then?
right now it's there. Most of them aren't running.
Because the pressure is so high is what you think?
The pressure's high and the discharge temp's low. So there's no
Okay.
demand for the discharge desuperheating, and then there's the pressure's too high to enable the liquid pump.
Okay.
So it just goes right through it.
Oh, okay. So it's not like an LPRV where it has to bypass it. You know, it'll still have proper flow through there, even if the pump isn't physically on. That's the only thing I was concerned about.
Correct. I mean, it's a centrifugal pump, so I mean, it's just gonna spin the pump.
Gotcha. And you said on the ones that you saw, no subcoolers on there.
It was 50-50. Some racks had subcoolers, some didn't, but they all had the same set points. So they would actually run it down lower than the subcooler. I mean, if you're running 100 pounds of saturated condensing temperature, I mean,
Yeah.
look at that for what's 100 pounds with
Or
for
gas.
any what's 100 pounds of 404?
Stay 25. I
What
don't
did
know
you
if
say?
I don't know. I just said 25. So
48 degrees. So I mean, yeah, you would be below most subcooler settings.
true.
So I mean, but at that point, you got to remember if you're running 48-degree saturated condensing temperature, your liquid's probably 40,
So
35.
does this also mean that the condensers are gonna have to be oversized?
No, they're already well, no, they're keeping them the same size. But you're essentially that condenser is oversized. Think about it. If you drop two pumps off a rack, and then they lower the split set point way down, so now that condenser, when in the wintertime where it would be half the size, is running full size condenser still. So I mean, you're essentially making that condenser bigger. It's already oversized in the middle of winter when you're sized for 110 and it's 35 degrees outside.
Okay. All right. I'm like I said, I've never seen one in person as far as like the ones at the Walmart, but like yeah.
There's actually a store in Denver that they took and completely shut off the medium temp rack in the wintertime.
Wait, what?
Yeah. So I was with a bunch of project managers from Walmart, and I was talking to this guy. He was that tech for the store.
Okay.
It's pretty cool. They took one of these liquid pumps on two medium temp racks, and when it gets below a certain outdoor ambient temp, I think he said it's like 20 degrees, they actually switch over to full LPA, bypass the compressors, and they pump straight liquid through the store. They're essentially cooling the liquid off using the condenser
Mm-hmm.
and basically turning it into a glycol almost.
I'm wrapping my head around it. So the pump is still cycling. You don't really need. You're still having to run it through some sort of condenser because even though you're not superheating the gas, you know you still need to circulate the shit around, which is the whole purpose of the pump. You're still picking up. You're still rejecting whatever little bit of heat is to turn it back into a liquid on there because
Yeah.
at that point it's gonna be super cold out anyway.
Yep.
And what's the ambient cutout typically? Like where
I think you said it had to be below 20 degrees for it to function properly.
20 degrees above your
No, 20 degrees below your set point, or like, so I think you said at 20 ambient, they were able to use it on, it was like a plus 25 rack.
okay.
But they're essentially circulating refrigerant around
Yeah.
without compressors.
Yeah, so exact almost like the liquid overfeed on the Walmart racks for the CO2, except for the fact that these particular cases have actual superheat control, where all the liquid pump overfeed CO2, those do not have any. All they have is a distributor, and they're basically just opening up based off of does it need liquid refrigerant or does it not. Where
Correct.
these still have to because you technically still have a compressor, so we don't want to. We can't go full on flooding back, so we have to do something, right?
Correct. So there has to be
Okay.
some kind of, metering in there. Obviously, they had to install. There has to be EVs installed. I didn't get that far, but there has to be EVs installed because they didn't have to bypass open at one point to allow that flow to come back.
Gotcha. And you
Yeah,
said you said out in Indiana they were like putting these all over the place or something?
almost every store has them. Like almost every single store that we have has them. So I mean, they haven't made their way into Illinois yet, but like they're all over Indiana, all over Michigan. Uh,
Wonder what the big push was.
they got an incentive probably from the utility, and
Uh,
then not even just that. I mean, a lot of these stores they did them on were stores that were like kind of older, condensers were in rough shape, and they did make a huge difference.
they were in rough shape. And I'm seeing there's also a check valve, basically bypassing the pump. Oh, it's bypassing the pump. So I guess that's what the flow of refrigerant will do if the pump is off.
Yeah,
It'll basically
it's gonna,
it won't go through the pump. It'll actually go
it's gonna take the path of least resistance.
resistance. Yeah.
So, I mean, other than that, like troubleshooting wise, guys, real simple. Just make sure your transistors all read right. Temp sensors, make sure the discharge lines are the temp sensors are insulated. I mean, I've come into
Wrap them.
what's that?
Wrap them.
Well, yeah. And that silver like insulation tape, if you could find it, like Brett's always talking about, I've yet to ever find it.
You breaking my balls, Mr.
Well,
Ruff.
I literally never, I don't even know where you could get it from.
Ari Michaels. Can you get a heating, please?
The hell's an R.E. Michaels?
It's one of those places that are like strategically for like an area. So like up in Pennsylvania, you have Myers Supply. Right. Down in Texas, you have Barsco, really big. So I mean, it depends on the area. It's almost like Texas is known for Buc-ee's, right? Kind of like that. Where
Yes.
Chicago's known for crime and
Yeah.
crime.
Yeah. You're not wrong.
So what is there any specific controller that's extra to this?
It's just a Corel controller that's doing all the logic. So they're using a Corel PCO to do all the logic. And
Yeah,
it's doing all the control.
I was trying to convince someone last week to get those, but he couldn't find one.
I just
Um,
want to get into the like PCOs and
Well-
like actually learn how to the programming set up, but it's like
here's the
impossible.
problem. I know. Well, here's the problem too. So you have Corel, which makes the thing obviously, and they sell them to other people because they want their they'll sell it to other manufacturers. But then what happens is if that manufacturer were to strip it down and basically create their own program and throw it in, you can't call Corel for help. So like Hill Phoenix has people that basically answer questions for that particular case because or that particular rack controller because once they put their name on it and they drop their own program, Corel's like nope, 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 it's not our program. So they don't know what they did. So basically, technical support falls back on the manufacturer of the equipment at that point.
which is super irritating because, like, obviously, that manufacturer of the equipment probably doesn't know that controller like as well as they should. And Corel,
Got no, do they? A lot of these manufacturers have invested. Like they actually have guys that I met some of these guys this week. They're brilliant. Like as far as the engineers that I talked to, like they know their shit. Like they hired specifically for that. I get what you're saying, but I think once again it's kind of like how you have like Carnot, right? Carnot basically takes the program out of the MT boards and then puts their own specific program in there, right?
yeah, and the reason they do that is you're basically married to them, so you're locked in.
Sounds like my wife.
It's basically like
Okay.
it's basically like being like kidnapped. I mean,
Sounds like my wife.
you're being held for ransom. I mean, at that point, like, here's my thing. You call Emerson with an Emerson product and say, this is what it's doing. Emerson will help you. Doesn't matter if Hill Phoenix programmed it, Husband programmed it, or Zero Zone programmed it. They're still going to help you. Same with
I
Danfoss.
I see both sides. You know what I mean? Well, yeah, but they're not. But they're not stripping down the freaking 255 or the 800 down to like back down to MS DOS prompt. You know what I mean? Like they're not.
They're not really doing that with Corel, I'm sure. I'm sure it still has the same basic like premise like in the background. I mean, you're not completely rebooting like it still has this.
Well, but we'll have that conversation. So I'm getting a guy on from Corel to talk about stuff. Like I want him to do like a visual one. I want him to something that we can actually look at because I know we're gonna ask a shit ton of questions. Like that one's gonna be a lot. We're gonna have to turn that into a two-parter when it finally comes to fruition. But
I
I
don't
just
know what it looks like on a laptop. Like, is it web based? Is it like, I mean, is it magic?
I don't know. It's like the HPV. It's the magic valve. It's the magic controller.
Stop saying that.
I know. If you're gonna get slapped by a Canadian, call the HPV a magic valve. They don't like it.
All right, guys. I think it's gonna be all on liquid pumped overfeeds
No,
or
like,
liquefaction.
go to fuck to bed.
Oh, I've talked about so much CO2 lately. That this is like, uh,
Kevin's brain is fried. That's what the new episode is called. All right, guys. See you next time.